Are you still struggling to obtain the solution of given quadratic inequalities? Watch this video to the end and I assure you, you will master the secret of solving given quadratic inequalities. First of all, quadratic inequalities are those inequalities of the form P of s greater than 0, or P of s less than 0, or P of s greater or equal to 0, or P of s less or equal to 0, where P of s is a given quadratic expression of the form as squared plus bs plus c. So if you encounter any quadratic inequalities of this form and you wish to get its solution, I have itemized 5 steps you need to take in order to obtain the solution. First, you have to move all terms to one side of the given inequality. Sometimes the given problem might not assume any of these forms, but by moving all terms to one side of the given inequality, you will re-express the form or the given problem to assume any of these forms. Now, the next step you need to take is to factor the given quadratic expression or make use of the quadratic formula to obtain the root of the given inequality. Now, if you have obtained the root, you then plot the roots on a number line. If you plot the root on a number line, the root will partition the number line into trail intervals. And so the next step you need to take is to test each interval to check whether they satisfy the given inequality. And then you have to choose the correct interval that satisfies the given inequality, because the interval that satisfies the given inequality becomes the solution of the inequality. Now let's make use of this problem to see how we can make use of these steps to solve given quadratic inequality. So I have that 3x squared minus 2x plus 1 is greater or equals to 2x squared plus 3x minus 5. Now if you observe, this problem does not assume any of these forms, but by moving all terms to one side of the inequality, we are going to get at least any of these forms. So we are going to obtain this solution right away. So we have that 3x squared minus 2x plus 1 is greater or equals 2x squared plus 3x minus 5. And by moving all these terms to one side of the inequality, that is by subtracting 2x squared from both sides, 3x squared from both sides, and adding 5 to both sides of this inequality, we are going to obtain that 3x squared minus 2x squared minus 2x minus 3x plus 1 and then plus 5 is greater or equals to 0. And if you should then collect like terms, 3x squared minus 2x squared will give us x squared, then minus 2x minus 3x will give us minus 5x, and then 1 plus 5 will give us 6. This is greater or equals to 0. So we have made this inequality to assume this form, and this is exactly the form that this given inequality have assumed. So the next thing now is for us to factor this quadratic expression since it is factorizable. But if it is not factorizable, we make use of the quadratic formula to obtain the root. Now, since it is factorizable, we go ahead and factorize it, and we are going to obtain s minus 2, s minus 3 to be greater or equals to 0. So if you factor this expression, this is what we are going to get. And so we are going to obtain the root of this inequality. And the root of this inequality simply means the value of x that will make this expression 0. And we find out that the root or the values of s is 2 or 3. So s equals to 2, we make this expression 0. And also s equals to 3, we'll also make this expression. So these are the roots of the inequality. And so we are now going to plot the roots on a number line. Remember, this is our number line. This is our number line. We have positive infinity here, and we also have negative infinity here. So suppose this is 0 here, then this is now 2, and this is now 3. So these roots have divided or partitioned this number line into 3 intervals. The first interval is the interval that ranges from minus infinity to 2. Then the second interval is the interval that ranges from 2 to 3. And then the third interval is the interval that ranges from 3 to positive infinity. So we're going to check whether these intervals satisfy the given inequality. Now we are going to first consider this interval. We are going to pick any value here and see whether it satisfies this. Suppose we pick 0 here, because 0 is on this interval. Then we are going to see 0 squared minus 5 times 0 plus 6. And if you do that, we are going to get 6. and 6 is greater than 0. That means that this interval satisfies this inequality. Now let us pick a number between 2 and 3 to check whether this interval also satisfies this inequality. Suppose we pick the number 2.5. 2.5 is in this interval, and if we should substitute 2.5 here, we are going to get 2.5 squared minus 5 times 2.5 plus 6. And if you do that, we are going to get minus 1 divided by 4, and this is less than 0, which means that this interval does not satisfy the inequality. Now we are going to choose another number in this third interval to check whether it satisfies this inequality. Suppose we pick the number 4 because 4 is in this interval. Then we are going to have 4 squared minus 5 times 4 plus 6. Now 4 squared is 16, then 5 times 4 is 20, then 16 minus 20 is minus 4, then minus 4 plus 6 is 2, which is also greater than 0. So this interval also satisfies the inequality. So the interval that satisfies this inequality is this interval from negative infinity to 2. Remember, 2 is inclusive because of this expression equals to 0, and then this interval 3 to infinity. So the solution of this inequality becomes the union of this interval that satisfies this inequality. So therefore, the solution is minus infinity to 2. 2 is inclusive, union 3 to infinity, and 3 is also inclusive. And this is how you solve given quadratic inequalities. See you in my next lesson.